Okay, so let's begin the discussion. This is the physics paper for NEET 2023. So the student just sent me the question paper. So let's start solving question number 1. So they're saying if the galvanometer G does not show any deflection in the circuit shown, the value of R is given by what? Okay, so as you can see here, this galvanometer is not showing any deflection, means there is no current, okay, coming out from this 2-volt cell. That means the voltage drop on this resistor here should be 2 volts. Now, out of 10 volts, I have 2 volts across this resistor. So I can say that the remaining 8 volts must be across this 400 ohms. Okay. So now, how much would be the current then? So the current I would be V by R. So 8 upon 400 amperes. So that current is also flowing through this resistor because nothing is going here because the galvanometer is showing 0. That means that the resistance value will be, I can say V by I. So the voltage value we said is 2 volts. The current we just figured out is 8 upon 400. So that 400 goes in the numerator. So 800 by 8, 100 ohms. So that is option 3. Okay. Question number 2. Given below are two statements. Photovoltaic devices can convert optical radiation into electricity. Yes, so photovoltaic devices are basically photocells, or you can say solar cells. And Zener diode is designed to operate under reverse bias in the breakdown region. Yes, this statement is also true. So both statement 1 and 2 are correct. Yes. Incorrect. It's okay. So then this should be the first one itself. Okay. Then question number 3. A full wave rectifier circuit consists of two PN junction diodes, okay, a central tapped transformer, capacitor, and load resistance. Which of these components remove the AC ripple from the rectified output? So basically, the rectified output means we have the output from the full wave rectifier is like this, and now we want to regulate it, right? So basically, so which of these components will remove the AC ripple? So this is the ripple. So which of these components will remove? So that should be the capacitor, because the capacitor would get charged and then discharged, because everything else is not going to, is just a part of the rectifier, right? So the full wave rectifier will consist of the transformer, the diodes, and the load resistance. But here an extra capacitor is put to take care of this part, because removing the AC ripple, okay, from the rectified output, that's not the job of the rectifier. The output is already rectified. Now we want to regulate it. So actually, it seems to be like a question on rectifier. It's actually on a regulator. So again, the answer here would be capacitor. Okay. The errors in the measurement which arise due to unpredictable fluctuations in temperature and voltage supply. So then definitely not an instrument error. Temperature error is not, temperature fluctuation is not because of instrument or personal or least count. It has to be random error. Then, so the fifth one. Yeah. So question number 5. Let a wire be suspended from the ceiling, rigid support, and stretched by weight W attached at its free end. Okay, so we have ceiling, and there's a wire, and we have a weight W. So the longitudinal stress at any point of cross-sectional area A of the wire is how much? So basically, longitudinal stress, okay, basically along the length, stress along the length. So basically, stress is force upon area, and the force which is pulling the wire down is the weight W. So W upon area. Now their question is, what is the stress at any point. So whether it is here or here or here, at any point of the wire, what is the stress? So the point to be understood here is that whenever you have, at any point, if you want to find out the stress, you should consider the force below that wire, below that part of the wire. Means uh, no matter which point I consider on this wire, this W is always below every point, and hence it is just going to be W by A. Right? Basically, the point to remember is that it doesn't depend on how much force is exerted from this ceiling. The force above that point doesn't matter. The force below that point is what matters, and the force below the point is below any point of the wire is the weight W. Okay, fine. Next one, the sixth one. The temperature of a gas is minus 50 degrees Celsius. To what temperature the gas should be heated so that the RMS speed is increased by 3 times. So VRMS. Okay. So the RMS speed formula, we can just say, is directly proportional to square root of the temperature. So if I want to increase the speed 3 times, what should be the temperature? For T1 is, I should say, minus 50 plus 273, because everything should be in Kelvins. So now V2, right? RMS speed is 3 times. So V2 is 3 times V1. Okay. So we are going to get V2 by V1 is root of T2 by T1, or we can just square and say T2 by T1 is V2 by V1 square, or 3 square is 9. So therefore T2 is 9 times this value. So 273 minus 50 would be 223. Right. So do they want in Celsius or Kelvin? Both are given. So let's multiply. We have 18, 27. So, and then 80. So this much Kelvin, but if I subtract 273 from here, so I will get 1734 Celsius. So this one looks like we don't have any option here. Neither there is an option with 2007 Kelvin, any option close than that, or neither there is a 17 or 1800 Celsius. Okay, so this seems to be an error here, question number 6. Okay, so maybe we can just attempt any one and click on any option and leave it, because temperature and RMS speed, this is a very clear relationship. Yeah, V2 by V1 should be root of T2 by T1. So, and we have to take it in Kelvin, not in Celsius. Okay, let's go to the next one, number 7. The magnetic energy stored in an inductor of inductance 4 microhenry carrying a current of 2 amperes. So this is an extremely simple substitution question. All we have to find out is half L I square. So half of L, which is 4 micro, I square, that is 4, 2 square is 4. So again, this goes up, 8 micro joules. That is option number 4. Question number 8. The equivalent capacitance of the system shown in the following circuit is what? Okay. So we have 3 parallel 3 microfarad. So this is going to give me 3 plus 3, 6 microfarad. And then that 6 along with this 3 is going to be give me what? The product upon sum. So I can say C equivalent is, they are in series. So 3 into 6 upon 3 plus 6 is 9. So answer is 2 microfarad. Okay. So that's the first page till question number 6. Second page here. Okay. So now they are saying Venturi meter works obviously on Bernoulli's principle. There's no doubt about that. The ratio of frequencies of fundamental harmonic. Fundamental harmonic is basically the fundamental frequency. So ratio of fundamental frequency produced by open pipe to that of closed pipe having the same length. So okay, so we just want the fundamental frequency. So n open upon n closed of the same length. So open pipe is V by 2L and closed pipe is V by, so that goes in the numerator, 4L. So I'm left with 4 by 2 or 2 by 1. So that is this option. Okay. Light travels a distance x in time t1 in air. Okay. So what can I say about x and t1? dst. Distance is speed into time. So x is c t1. And it travels a distance of 10x in time t2 in another denser medium. So 10x is some denser medium. So let's just say v medium and time is t2. So what is the critical angle for this medium? So first of all, let's just divide these two. So I will get x upon 10x. This x and x will get cancelled off. It is 1 by 10. So I have ct1 upon vmt2. So what I get is, you can say c by vm is going to be t2 by 10 times t1. And c upon v is nothing but speed of light in air upon speed of light in the medium. So I can say this is nothing but mu of the medium with respect to air. It's the absolute refractive index of the medium. So the refractive index of the medium is t2 by 10 t1. But refractive index also has a formula for denser with respect to air. So 1 upon sine AC, and that's what they are asking us. They are asking us what is the critical angle. So I'm going to get sine IC is going to be 10 T1 by T2, or IC is going to be sine inverse of 10 T1 by T2. So it seems to be this option number 4 here. Sine inverse of 10 T1 by T2. Yes. Okay. Number 12. So closed loop integral of E bar dot ds bar is equal to 0 over a surface. This is related to our Gauss theorem. So number of flux lines entering the surface must be equal to the number of flux lines leaving it. Okay, and the second option, the magnitude of the electric field on the surface is constant. All the charges must necessarily be inside the surface, and the electric field inside the surface is necessarily uniform. So if you think about it, this here, what they are saying is, if I just multiply by epsilon in the numerator here, I mean the LHS, then multiply by epsilon the RHS, epsilon naught. So basically what we have here is, this is nothing but the TNEI. And we always know that TNEI is summation Q, and that value they are telling us is 0. Okay. So number of flux line. So I mean, if I think of this option, the magnitude of electric field on the surface is constant. There is no field because there is no charge. All the charges must necessarily be inside the surface. I mean, there is no net charge. I can have a plus 2 coulomb, minus 2 coulomb, and they can cancel each other and give me 0. So are all the charges must necessarily be inside? Yeah, that can be possible, but then effectively it is 0. The electric field inside the surface is necessarily uniform. No, there is no charge. And even if there were some charges, say there is an arbitrary surface and I have some charges Q1, Q2, Q3 plus Q3 adding up to be 0, then it's not necessary that I should have a uniform field. So if we think about it, considering TNEI is 0, because they are talking about in option 2, they are talking about electric field on the surface. So then again, we would not, I don't think so there is anything okay on the surface. Now these two options seem to be correct, but here this one is slightly tricky because they are saying all the charges must necessarily be inside. Yeah, that's true, but then what if it is 0? There is no charge, right? Then this would make more sense, because even if there are some charges, okay, even if there is, say there is a plus q and a minus q and they add up to become 0, if this is happening, then this first option is always true, even if there is a plus q and minus q, but this third option will not be correct then. All the charges must necessarily be inside. Yeah, I mean, yeah, that is also true. But if I have 0 charge, then this third option is not correct. So third option is conditionally correct. First option is always correct. So I think we can go with the first option. Okay. So now number 13. Um, so again, we can just move on to the next page. Question number 13. Okay, so there is a 12 volt 16 watt lamp and it's connected to the secondary of a step down transformer. So we are giving it an AC source, but the lamp, this usually we consider as the RMS voltage, DC voltage. So anyway, so whose primary is connected to the AC mains of 220 volts. Assuming the transformer to be ideal, okay, what is the current in the primary winding? Fine. So uh, transformer is ideal. So what does that mean? Input power and output power is the same, or I can say um, E primary, I primary is equal to E secondary, I secondary. One thing is clear that in the primary, I have 220 volts. What is current in the primary? The current in the primary is what is to be found out. Current in the primary only. Okay, and this is the power basically. And output power is given to us as 60 watts. So whether I consider it AC or DC, the power would still be 60 only, right? So then whether it is 12 volts or whatever volts it is, it doesn't matter. So I would just say IP is nothing but 60 upon 220, or we would get uh, 3 upon 11 amperes. So suppose if I had 10 amperes, then it would be 0.3. Instead of denominator being 11, if it was 10, the answer would have been 0.3. But because my number here is a little bit more than 10, I would have an answer slightly lesser than 0.3. So is there any option here less than 0.3? If you look at the option, yes, there is a 0.27. So I think we can go with that. Okay, number 14. The minimum wavelength of X-rays produced by an electron accelerated through a potential difference of V volts. So we want the minimum wavelength value. The minimum wavelength formula is Hc upon E times V, or 12375 angstroms upon V. So So basically it is inversely proportional to V. So V is the voltage, right? So it should be this option here. Okay. So number 15, the amount of energy required to form a soap bubble of radius 2 centimeters. That means the initial radius is 0. The final radius is 2 centimeters. Let's just call that as R. And is nearly how much? And surface tension is given to us as 0.03. So I would say 0.310 raised to minus 2 newtons per meter. And what do they want? So we will use a formula W is equal to TdA. So it is a soap bubble. So soap bubble we will have to consider as uh, 8 pi r square. So 8 pi final area is, we will have to consider double area inside and outside. So 4 pi r square, double of that is 8 pi r square. Final area is 8 pi r square and initial area is 0. Fine. So we have T into 8 pi r square. So this is going to give us 3 into 10 raised to minus 2, 8 pi. Let's just keep it at 3.142, 20 to the 7 will not make any difference. And then r square, so 2 square is 4, and raised to minus 4. So I'm getting 24 into 8 into 3 is gone, so I'll still have 4, I still have 3.142. Power of 10 is going to become minus 6. And yeah, we have The powers as -4, so that's fine. So now all the powers are sorted out. So what we should do is we should take the decimal behind by 2. So I have 0.24 into something above 12. So we can do an approximation here. So let's say 13, and this is going to be 10 raised to -4. So now my power of 10 is sorted because everywhere is 10 raised to -4. What would this number turn out to be? So it's between 2 and 3. So I would say something around 13 into. So it should be something around 3. It would definitely not be 30. It would definitely not be 5 or 50, right? So this has to be the third option. Okay. The magnitude and direction of the current in the following circuit is what? Okay, this is quite easy. So we have 10 volts and 5 volts opposing each other. So because the 10 volt has more EMF, it will dominate. So the resultant is going to be 5 volts. So if I want I, I would be the resultant EMF is 5 volts. 10 minus 5 is 5. And the resultant resistance is just add all of them. So 7, 8, 9, 10. So 10 ohms. So V by R, half ampere. Okay, so half ampere, there's only one option. And anyways, what would be the direction? It's going to be the direction as liked by this cell, which would be from A to B. So 0.5 amperes from A to B through E. Yes, so this is the right. Anyways, there is only one option with 0.5 amperes. So, okay, number 17. The work functions of cesium, potassium, and sodium. Okay, so these numbers are given to us. Uh, Cesium work function is 2.14 eV. Sodium, sorry, potassium is 2.3 eV, and sodium 2.14 eV. So, no, sorry, 2.7. The first one, 2.75 eV. Okay, so 2.14, 2.3. Now, if the incident electromagnetic radiation has an incident energy of 2.2 eV, which of these photosensitive surfaces may emit photoelectrons? Oh, this is very simple. So if you want KE, you want kinetic energy, okay, it should be your incident energy, which is 2.2 minus phi naught. Now, any one of these or multiple of these we could take. But if I take any number more than 2.2, I'm going to get a negative kinetic energy, or basically I'm not going to get any photoelectric effect or photo emission. So basically my number here, phi naught, should be less than 2.2. So obviously these two will not create any photoelectric effect. It should be only cesium. Okay. May emit photoelectrons. So cesium only, sodium and potassium should not happen, because the number should be this number here, phi naught. Right? The work function should be less than 2.2. So that's number 17. Let's go to the next page. Question number 18. So the net magnetic flux through any closed surface. Well, if it's a closed surface, what should it be? So what we can do is just consider, say, a bar magnet. Okay. So if we have a bar magnet, just something to think about. So I have a magnetic field like this. So now, if I take a closed surface, so if I don't take a closed surface, suppose if I just take a surface somewhere random, say like this. So if I take a surface like this, then the net field is not zero because I have the lines of force, right? So say, for example, this is the north and the south pole. So I have the lines of force going in one direction. They are entering, they're cutting through the area. So there is a flux through the surface, some positive flux or negative flux. Again, it depends on what direction you want to consider. But if this surface is a closed surface, okay, if I consider a closed surface, then the net field is zero. I mean, there is no field entering or leaving Okay, if the closed surface is assumed to be, enclosing the entire field, then it should be zero. So zero makes sense. Okay, in a plane electromagnetic wave traveling in free space, electric field component oscillates sinusoidal at a frequency. This is basically the frequency of the wave and amplitude. So we can just call it as maximum amplitude E naught. Then the amplitude of the oscillating magnetic field is how much, and speed is given. So again, this is very simple. All we have to do is use the formula for C. Okay, so which is going E naught by B naught. So all that I have to do is now B naught is equal to E naught upon C. So the E naught value 48. It's a units, yeah. And C is nothing but 3 into 10 raised to 8. So this frequency is useless basically here. 3 1 is 3, 6 18, 10 raised to minus 8. Or if they want 1.6, then I should say 1.6, 10 raised to minus 7. So it should be this. Okay. Number 20, bullet is fired from a gun at a speed of, let's say U is 280. Direction of, let's say theta, 30 degree above the horizontal. So yeah, maximum height. Oh my god, this is extremely easy again. So we just have to use the formula for height, that is U square sine square theta upon 2 times G. So that is going to turn out to be U square. So 280 into 280, or let's keep it as 28 into 28 into 10 raised to 2. And sine 30. So sine 30 is half. Again, they're being very kind to you. We are giving you the value of sine 30. Half squared is 1 by 2 square is 1 by 4 divided by 2 times G, and this is not so great here. They want us to take 9.8. Okay, fine. So 4 is a, then 2 is a, 7 is a, again 4 is a. So I have 4 is a 21.4. So I have 114 upon 1.4, which is 10 into 10 square. So I have 10 raised to 3. Now basically it is 1000. So is there an option? Yes, there is an option. 1000. So maximum height. Okay. 21. So they're saying an electric dipole is placed at an angle of 30 degrees with an electric field of intensity. So theta is given to us, that's 30 degrees. With an electric field, so I would say E is 2 into 10 raised to 5. It experiences a torque. So we will have to make an assumption that this is a uniform field. I have not said that in the question. Okay. It experiences a torque equal to 4 Newton meter. Calculate the magnitude of charge on the dipole. If the dipole length, so which is what we call as 2L, is 2 centimeters. So we can just use the formula for torque. Torque experienced by a dipole in a uniform field, electric field, we can say is PE sine theta. So we can get P, which is tau upon E sine theta, and tau and E and theta are given to us, and P is nothing but Q times 2L. So what we want here is Q, charge. So it's going to be tau upon E sine theta into 2L. So that's it. Very simple substitution question. 4 divided by P 2 into 10 raised to 5. Sine theta, sine 30 is half. 2L is 2 into 10 raised to minus 2. So I'm getting 2 2s are 10 raised to 5, and minus 2 is 10 raised to 3, which goes in the numerator and becomes minus 3. So is there an option 2 into 10 raised to minus 3, which is 2 millicoulomb? Yeah. Okay. For YDSE, two statements are given. If the screen is moved away from the plane of the slits, okay, the angular separation of the fringes remains constant. No. The fringe width would increase and the angular separation would also increase, right? Because x is lambda capital D by small d. So if you increase capital D, x is bandwidth is going to increase, the bands are going to get wider. So the separation between the angular separation is obviously going to increase. So statement 1 is wrong. Statement 2, if the monochromatic source is replaced by another monochromatic source of larger wavelength, so again you have increased the wavelength, angular separation of the fringes decreases. Again, this is wrong because x is directly proportional to lambda. So both statements are false. So we'll go with number 2. Okay. 23. Football player is moving southward and suddenly turns eastward. Yeah, so this diagram which he has drawn is correct. South, and then he suddenly turns east. And what about the speed? With the same speed to avoid an opponent. Right. So the force that acts on the player while turning. Okay. So the momentum, initial momentum, I can say mv1 bar, okay, is in this direction and then it is in this direction. So force is change of momentum upon time. So in which direction is the momentum changing? And let me do this. Write this here. Oh, solve it here. Question number 23. So force is change of momentum upon time. So we're not bothered about the magnitude of the force. All we need is the direction. So in which direction is the force? So all I have to do is I have to find out delta P, the direction for delta P. So it is P2 minus P1. So this is my direction of P2, okay, which is mv2 or mv in this direction. This is the final momentum, and the initial momentum I wanted negative. So initial momentum is actually down south, right? But I'm going to take it up. So this is my P2 bar and this is my minus P1 bar. You have to add these two. This P2 minus P1 is nothing but P2 plus minus P1 bar. I have to add a negative vector. And the vector P1 initially is in south, so negative of P1 is in north. So this vector, so now what I want is addition of this vector and this vector. So this vector plus this vector. So as per the triangle law, it's going to be in this direction, which is the it's not the east, it's the not the north, it is the northeast. It's the northeast direction, right? North and east, northeast direction. Fine. Question number 24. I think you should go it on the next page. Okay, so there is a metal wire. Metal wire has mass, radius, and length are given to us. Maximum possible percentage error in measurement of density. Okay, fine. So this is just about error, percentage error. So first of all, what we will do is density is mass upon volume, right? And mass is given to us 0.4, and volume can be written as volume of the wire. So I would say pi r square L. Right? If I have a wire, cylindrical wire, radius of cross section is r. So area of cross section pi r square into length L. This is going to give me the volume. So I can say therefore density is proportional to mass, inversely proportional to square of the radius, and also inversely proportional to the length. So I would say r raised to minus 2, L raised to minus 1. But what I want here is percentage, not change, but percentage error. What we want is percentage error. So since we want percentage error, I would say in rho is going to be percentage error in m. Now, although this both the powers here are negative, if you want percentage error, you have to still consider positive power because errors are always additive in nature. So plus 2 times percentage error in radius plus 1 time percentage error in length. If this was percentage change, I would have taken the actual power. I would have written minus 2 and I've written -1. But because this is error, not change, I will take positive numbers only. So that's it. What is the percentage error in measurement of mass? So I would say the delta m value, which is 0.002 upon the original mass value, which is zero point 0.4, and both are in grams, so it doesn't matter, into 100, plus 2 times, same thing for radius, uh, the delta r value, which is 0.001 upon the original radius, again both are in millimeters, so the unit doesn't matter, into 100, plus 1 into, for length how much it is, 5, so 0.02 upon the original is 5, again both are in centi, so the unit gets cancelled off, into 100. So now what numbers do we have? So into 100 means this is 2 10 raised to -1 upon 0.4 is 4 10 raised to -1. I would say 2 into, what is this, into 100, so 0.1, 0.1 by 0.3, okay, or which is nothing but 1 by 3. I could have done that here also. Let's say 2 by 4. Yeah. And this third one is 2 by 5. So 2 by 4 is 0.5, 1 by 2. This is 2/3, means 1/3 is 0.30, 0.66 recurring, so 0.67, let's round it off. And this is going to be 5 4s are 20. So that's it. Add all these up. So let's say 0.5 plus 4 is 0.9, 0.9 plus 0.67, so 1.57%. Or if you want, because they are saying nearly, I would say 1.6%. Okay, so there's this one. Okay, now an AC source is connected to a capacitor C. Fine. Due to decrease in its operating frequency, capacitive reactance. So basically, capacitive reactance is what? 1 upon 2 pi Fc. So you are going to what? Decrease the frequency. So if F reduces, denominator goes down, this Xc value is going to go up, right? So capacitive reactance decreases, wrong. Displacement current, again, and then they're talking about capacitive reactance remains constant. So again, this is wrong. So basically, we have to talk about the displacement. Ignore the word displacement. Just talk about the current. So if I assume, assuming fixed voltage, because they have not said anything about the voltage, they have just said the frequency is reduced. So then, if I talk about I, so V, or because it is AC, you can say E by XC. So again, now XC is increasing. So again, the current would decrease. So it should be this third option. Okay. So fourth page now, question number 26. Okay, so another easy one here. They are asking resistance of a carbon resistor is determined from the color codes. So we need to know the color coding. B.B. Roy of Great Britain had a very good wife, right? So that we make use of that. So yeah, so what is the number again? 2, 2. So I can write it as 22 into 10 raised to 123 plus minus 5% ohms. So the color of the third band. So these are my 2 digits. This is the third band and this is the fourth band. So the third band is the power of 10, which is 3. So the number 3 would be for P, if I consider B, B, R, O, Y. So this is 0, 1, 2, 3. So the number 3 is basically orange. Okay. Then the next one again. Carnot engine has an efficiency of 50% when its source is at a temperature of, so that is T1, is 327 plus 273. This will give me 300, 400, 500, 600 Kelvin. And the temperature of the sink is what? Oh, again, very easy question. It's going to be T1 minus T2 upon T1. So what we want is T2. So efficiency is 50%, or basically it is 50 by 100. So 50 by 100 is 1 by 2. So again, pull T1 in the numerator is T1 minus T2. Or you will get here T2 is going to be T1 minus T1 by 2. There is nothing but T1 by 2. So half of 600 or 300 Kelvin. So do they want it in Kelvin or Celsius? They want it in Celsius. So 300 minus 273. So this will give me 27 degrees Celsius. Okay. Theory question. The angular acceleration of a body, that means alpha, moving along the circumference of a circle. So what is the direction? I think they are asking. Along the radius, along the radius, along the tangent, and it's along the axis, because alpha, omega, and theta, all three are given by the right hand thumb rule, and the direction of rotation is given by the curled fingers, and your thumb is pointing along the axis of rotation. So it is this 4. Okay. In a series LCR circuit, the inductance L, okay, is 10 millihenry, capacitance C is 1 microfarad, okay, and resistance. So frequency at which resonance occurs. So they want the resonant frequency. Again, very simple question. Let's do it on the next page. Right. So question number 29, resonant frequency 2 pi root of LC. They want it in, they want it in radian per second, as well as two options are in radian per second. That means they're talking about omega, and this is in hertz, so that means they're talking about f. This is quite tricky. Anyway, so let's just find out that root LC first. So what is the L and C? L is 10 millihenry, so 10 milli, and what is the C value? 1 micro, okay, minus 6. Right? So we have 1 upon 2 pi root of 10 raised to minus 6 minus 3 is minus 9, plus 1 is minus 8, square root of that is minus 4, goes in the numerator, becomes plus 4. So now if I want f, it is this, but we want the numbers 15, 1, 5 and 9. So definitely it doesn't seem to be omega, because if I consider omega, then this 2 pi would be in the numerator, right? 2 pi f, and I would have got to 10 raised to 4, which is not, doesn't seem to be an option here, right? There's no 10 raised to 4. The numbers are, 159. We need to get the digits 1, 5 and 9. So let's keep this as 10 upon 2 pi, which is 6.28, and write it as 10 raised to 3. So this is nothing but kilohertz, and this 10 upon 6, okay, would be giving me 1 point something, and you can just guess from here it should be 1.59, and I want it in kilohertz, so that's my answer. Okay, number 30. Vehicle travels first half the distance with speed v, and the remaining distance with speed 2v. So what is the average speed? Oh, this is quite easy. So what we want here is V average. So our formula for V average, right, is going to be D1 plus D2 upon T1 plus T2. So the distance D1 is half of it, half of the total distance. So let's say D by 2. D2 is also D by 2. Okay. Now what do I do with time? So the motion in both the cases is dynamic equilibrium, right? So time is distance upon speed. So the distance is d by 2, okay, and the speed is v, and the remaining distance with speed, distance is again d by 2, and the speed is 2v. So what is the average speed? Again, this is going to be d. I can take d by 2v constant here. So I have 1 plus d by 2v is 1, so this 1 by 2 is remaining. So I have, this is equal to 2v in the numerator, okay? This 2v goes in the numerator. And then in the denominator, I have 1 plus 1 by 2, which is nothing but 3 by 2. So again, that 2 goes in the numerator. So I have 4v by 3. That is this option. Yeah. 4v by 3. Okay. 31 seems to be a standard question again. So in hydrogen spectrum, the shortest wavelength in the Balmer series. So the moment they say Balmer means P is equal to 2. We want the shortest wavelength. So En minus Ep is Hc by lambda. So if I want lambda denominator minimum, then this gap should be maximum. So maximum gap means it should come from infinity. And that wavelength is lambda. So what is lambda then? 1 by lambda is equal to rz square, that is 1. 1 upon p square minus 1 upon infinity is 0. So it's r by 4. Okay. And the shortest wavelength again. So again the n value is infinity because the gap is gap minimum means the wavelength. Sorry, gap maximum means the wavelength minimum. Yeah, and we want shortest wavelength. So bracket says, so Lyman, Balmer, Paschen, bracket and fund. So Lyman, Balmer, Paschen, bracket would be 4. So if I do this, what do I get? Let's call that as lambda dash rz square 16. So I have r by 16. Again 1 by infinity is 0. So I have r by 16 can be written as r by 4 into 1 by 4. And this r by 4 is nothing but my, from equation 1 it is lambda. So I have 4 lambda. So that's it. Lambda dash is 4 times lambda. So that is this option. Okay. Okay, ratio of, I should go on the next page. So ratio of radius of gyration of a solid sphere of mass m and radius r about its own axis. So we want k for solid sphere over radius of gyration of the thin hollow sphere of the same mass. So solid sphere and hollow sphere. Same mass and radius. So mass is same, radius is same. Okay. So this ratio we want. So fine. First let's find out the k value for solid sphere. So 2 by 5 mr square solid sphere is mk square kss square. So my kss is going to be root of 2 by 5 times r. And for the hollow sphere, it is 2 by 3 mr. Same mass, same radius. So same m, same r. mk hollow sphere square. So my k hollow sphere value is root of 2 by 3 times r. All I have to do now is take a ratio of these two numbers. So I have root of 2 by 5r divided by root of 2 by 3r. So I have root of 2 by 5 and root of 3 in the numerator, 2 in the denominator. So root of 3 by 5. So this one again looks like it's a printing mistake. It should have been square root of 3 by 5, not just 3 by 5. Right? So, or they should have said ratio of the squares of the radius of gyration. So then if you would have squared it, again the k square, that would have given us 3 by 5. So I think seems to be a printing mistake. Question 32 again. So I'll go with the first option. Okay, so the half-life of a radioactive substance is 20 minutes. In how much time the activity of the substance drops to 1/16th of its initial value. So that would be in one half-life. Okay, again this is quite easy. Question number 33. So you can say time versus the activity. So t equal to 0. The activity is, or the I have n0. Okay, and so I want 1 by 16th of the initial value. So after 1 half-life, I have half. 2 half-lives, I have half of that. 3 half-lives, I have half of that. 4 half-lives, I would have. And 0 by 16, which is what they are saying, 1/16th of its initial value, activity or the sample value, whatever you consider. So n by 16 they want, right? Yeah. So then it would be 4 times the half-life. So 4 into 20, so 80 minutes. Question number 34, gravitation question. So two bodies of mass m and 9m, bigger body 9m, placed at distance r, the gravitational potential on the line joining the bodies where the gravitational field equals 0. So suppose there is some point here where there is some capital M mass kept, and let the distance be x. So this is r minus x, and here the field is 0. So where is this point? Field is 0, that means the force is 0. That means G capital M small m upon x square is G capital M 9 times small m upon r minus x whole square. Gm1 m2 by r square, that's what I'm using. So Gmm cancelled off, so just take square root. So you have 3 by r minus x, cross multiply. You have r minus x is 3x, or r is nothing but 4x. X is r by 4. So this is r by 4. Okay, you can update the diagram. This is r by 4, and this is 3/4 of r. Fine. So what do they want there? They want the gravitational potential. Okay, where on the line joining the two, where the gravitational field is equal to 0. Yeah. So what is the gravitational potential here now? Potential is simply a scalar quantity. So I would just say V is, again, it would be negative. So minus G m by x, which is r by 4. And the second one is minus G its mass, which is 9m, upon its distance. So again, this was 1/4, so this is 3/4. So the distance is 3r by 4. So all I have to do now is I can take 4gm and r as a constant, 4gm by r. So I have minus 1 minus 4 is gone, g is gone, m is gone, r is gone, 4gm by r is gone. So I have 3. So I have minus 4 for 16 gm by r. Is that an option? Yes, that is an option. Okay. Question number 35. Potential energy of a long spring when stretched by 2 centimeters is u. Okay, and if the spring is stretched by 8 centimeters, what is the potential? Oh, this is quite easy. So potential energy, I have to do it here. So potential energy is half k x square. So in this case, how much is x? 2 square. 2 square is 4. Right? Or just keep it like that. Half k 2 square, and u dash is half k. The new extension value is stretched by 8, not further by 8. Just 2 becomes 8. So I have 8 square. So they want the energy stored in it. So u dash value we want. So just divide the 2. U dash upon u is half k. 8 square is 64. Half k 2 square is 4. Half k cancelled. So 4, 16 there. So that is 16 there. Okay. Truth table. Following logic circuit, the truth table is what? Okay, this is again very easy. This is a NOT gate. The two here are NOT gates at the input. NOT gate, NOT gate. And this is again NAND gate. So if you want to bring the bubble, the NOT gate bubble at the output to the input, then what you have to do is convert this AND to OR. So now this NOT and this NOT and this NOT will cancel each other. So all I am doing is A plus B. A plus B means 0, 1, 1, 1. So it should be this one. Addition. Maximum acceleration of a car so that the body lying on the floor of the car remains stationary. Coefficient of friction, body on the floor is 0.5. Okay, so this is again quite easy, 37. So this is the floor of the car or something, whatever. This is the body, downward mg, upward is the normal reaction. The car is accelerating, let's say in this direction, then the body will experience, the passenger will experience a pseudo force in this direction, which would be equal to mass of the body into acceleration of the car, and hence the friction would be this way, which is mu times n, and n value is mg. So that's it. Mu mg is equal to ma. The a value, which is what they want, is mu g. So 0.15 into 10 is 1.5. Okay. Radius of innermost orbit of hydrogen atom is this much. So that's my R0 value, or you can say R1 value. Innermost orbit means the first orbit. So R1 value for n equal to 1 is 0.53 angstroms, or 5.3 times to minus 11 meters. Fine. What is the radius of the third allowed orbit of hydrogen atom? Third allowed, basically they want R3 is what? So we know the formula, right? Radius is epsilon naught h square n square up over pi me square z. So basically the radius is proportional to n square. That's all we have to do here. So that's it. R3 upon R1. Okay, R3 upon R1 is going to be in this case 3 upon 1 squared 9 by 1, right? So is that an option? 9 times 5.3 into 10 raised to minus 11. So they want in angstroms. So again, 9 into 0.53 angstroms. So half of 9 is 4.5, or little over 4.5 would be 4.7. Okay, 39. So bullet from a gun is fired on a rectangular wooden block with a velocity u. Okay, so this is a bullet fired with velocity u. When the bullet travels 24 centimeters through the block along its length horizontally, velocity of the bullet becomes u by 3. Okay, so suppose it goes from here to here, which is 24 centimeter, and u becomes u by 3. Okay, so then it further penetrates into the block in the same direction before coming to rest exactly at the other end of the block. Wow. So it stops here. So this is 24. How much is this? So what they are asking us is total length of the block. What is the total length of the block? So if you think about energy, so the kinetic energy lost is let's say half m. Let's say initial kinetic energy is u. Okay, and the final kinetic energy is 0. So half mu square, that delta ke, and that is a work done. And work done is force into displacement. And the thing is, the force value we don't know. Okay, so call this as equation 1. But if I use, instead of going from u to 0, if I go from u to u by 3, then what do we get? So we have half mu square minus half m u by 3 square, which would be u square by 3 3 9. This would be again, the resistive force offered is the same, and the displacement now is 24. So from here I get, if I take half m u square common, I get 1 minus 1 by 9, which would be 8 by 9. It's 24f. So what I wanted was f. So f is 1 by 24 into 8 by 9, half mu square. So what do we get here is, again, this is in centimeters. So this is in centimeters. So keeping that in mind, the S value would also be in centimeters. So if I just put that back into equation 1, I get half mu square is equal to F, which is 1 by 24, 8 by 9, half mu square into, this is the whole F, right? Yeah, into S. So just cancel off this. 3s are, so 9 3s are, I should get 27 centimeters as the total. But yeah, so that's what I want. The total displacement is 27, length of the block, right? So it should be this 27 centimeters. Okay. Net impedance of the circuit shown in the figure will be what? 50 hertz is the frequency, and these two are given to me. So let's find out XL and XC first of all. So let's go to the next page. So we have, how much is XL? 40. 2 pi FL. So I have 2 pi, what's F? 50 hertz. What's L? 50 by pi. Milli is 10 raised to minus 3 Henry. Okay. So I have pi cancelled off. 50 into 50, 2500 into 2 into 10 raised to minus 3, or I have 5000, right? 25 into 2, 2500 into 2 is 5000. So this is 1, 2, 3, 5 ohms. And what about XC? Same thing, the denominator. So 2 pi F, again, what is F? F is 50. C value this time is 10 raised to 3 upon pi micro. So minus 6. 3 micro is minus 6. So pi got cancelled off. So I have 52 is 100. 100 is 10 raised to 2. And this is 3 minus 6 is minus 3. So 10 raised to 2 and minus 3 gives me 10 raised to minus 1 goes in the numerator, becomes plus 1, 10 ohms. So it's capacitive. The resultant circuit is capacitive because X is more than XL. So anyways, what we want is net impedance. So now it's going to be very easy. Z root of, they're in series, right? So root of R square plus XL minus XC, or in this case I can say XC minus XL, the whole square. I mean, it doesn't matter. So what is the value of R? It's 10 ohm. So 100 plus, this is 10 minus 5. So 5 square is 25. So I have square root of 125, or I can write this as 25 into 1, 2, 3, 4, 5. So I have 5 root 5 ohms. Is there an option? Yes. Fine. 41. A satellite is orbiting just above the surface of Earth with period t. So just above the surface. A second. Right. So just above the surface with period t. So that means h is negligible. So small r is approximately equal to capital R. D is the density of Earth and G is the universal constant of gravitation. The quantity 3 pi by GD represents what? And we want the answer in terms of T. So let's just use the formula for T, right? For T1. Yeah. So T is 2 pi root of R cube divided by G times M. So what do they want? They want 3 pi GD. So they don't want a root here. G is not in the root. So let's just square. T square is 4 pi square. Now this small r is approximately equal to capital R. It's r plus h and h is negligible. So capital R cube upon gm. Okay. What do they want? 3 pi. So upon g times d, d is the density. Okay. So let's replace mass with density into volume. 4 by 3 pi r cube. 4, 4, 1 pi gone. So I have 3 in the numerator, pi in the numerator, nothing else in the numerator. I have g, rho, and that's it in the denominator. So what did they want? 3 pi over gd. I mean, not rho, their density is d, gd. So 3 pi upon gd is t square. Silly one. Okay, 42. A very long conducting wire is bent in a semicircular shape. It is a semicircle, A to B. So current is entering here, semicircle, and then current is leaving here. Okay. As shown in the figure, the magnetic field at point P for steady current configuration is what? So where is point P? Is the center. Let's assume it's the center. Okay, fine. So we have basically three shapes. First, second, third. We have two semi-infinite wires and one semicircle. Okay. So what do we get? So, uh, what do we get here is with a semicircle 1, 2, 3, and let's just assume it's a semicircle. Okay, and this is point P. So we want the net magnetic field, right? Yeah, magnetic field. So what is B1 plus B2 plus B3 in vector form? We have to add, and they want the direction as well. So let's first talk about the direction. So the current is entering here for one, going like this, and then coming up. Okay. So entering here means if I use the right hand thumb rule, as per the right hand thumb rule, right, I would have lines of force like this. So at point P, it would be going into the pitch. So B1, I can say direction is into the pitch, means cross. B2 is again right hand thumb rule, it will be out, so dot. And B3 is again going to be into the page, so again cross. So I have two additions and subtraction. I mean one out. So let's assume that this B1, B3 is more. So these are anyways magnitude is the same because the distance of point P from the wire A and B is the same. Magnitude of the direction, the magnitude of the current is same, distance is same, the direction is the same. So all I have to do is I have to actually literally add B1 and B3, or just double any one of them and subtract it, subtract B2 from it. So my B is going to be double of B1 minus B2. Let's do it like that. So again, now the first thing we have here is a semi-infinite wire. So I would say mu 0 I upon 4 pi A sine phi 1 plus phi 2. So if you think about it, one angle, right? One of the angles is 0, the other angle is 90. So sine 90 plus sine 0 is going to be 1 plus 0 is 1. So this is my 2 times B1, and B2 is going to be circular coil. So half of that. So mu 0, number of turn is half I, mu 0 and I upon 2 times R. So again, what is the R value? The R value is R. And what about this A here? This A value is also, if you see the diagram carefully, it is the same. It is R. Perpendicular distance is R. So you have to put R, not A. So that's it. This is the answer. I get, what should I take common? Mu 0 I by R. In fact, 4 also. So I have mu 0 I by 4 R gone. So I have 2 by pi. Okay. Minus mu 0 I by 2 to the 4 R minus 1. So what are my options? Mu 0 I by 4 R. Do we have that in the denominator? Yes, we have mu 0 I by 4 R, mu 0 I by 4 R, but we also have the bracket. So these two are not true. So 1 minus 2 by pi. No, it's 2 by pi minus 1 because I took cross as bigger. So 2 by pi minus 1 into the plane of the paper. Or if I want to write it as 1 minus 2 by pi, then it is out of the plane of the paper, away from the page. So into the page is 2 by pi minus 1. So this is wrong. Okay, because into the page, it should be 2 by pi minus 1. But out of the page, away from the page, then I can take, then this number would be positive, this number would be negative. So I would get 1 minus 2 by pi. Yes, so I think we should go with this option. Okay, so let's go to next page. Fine, so the last one here. Keep it like this. Okay, so question number 43. The resistance of platinum wire at 0 degrees, so that's my R0, is 2 ohms, and at and 6.8 ohms at 80. So RT is 6.8 ohms, right? And the T value is 80 degrees Celsius. And the initial value is 0. So the temperature coefficient of the resistance is what? So I just have to do alpha RT minus R0 upon R0 T. So what is the RT value? 6.8 minus 2 upon 2 into T. 80 minus 0 is 80. So that's it. This is quite simple. 6.8 minus 2 is 4.8 and 2 into 80. So 2.4, let's say 24, 10 raised to minus 1 into 8 to 10. 3 and 10 raised to minus 1 minus 1 minus 2, so 0.03 or 3 10 raised to minus 2. So again, this is very easy question for you. Okay, last page now. Alright, so what are they saying now? 10 resistors, each of resistance R, are connected in series to a battery of EMF E and negligible internal resistance. 10 resistance, each of resistance R. So we have 10 R. So we have 10 R in series with the battery. Negligible internal resistance. EMF is okay. Then those are connected in parallel to the same battery. So then I have 10 by R. Sorry, R by 10. And same battery. So no internal resistance again. So and the current is increased n times. Okay. So if the current is I here, then the current here is Ni. So what is the value of N? Okay, fine. So this I is E by R, and this Ni is E by R by 10. So 10 goes in the numerator. So N times I, but I itself is E by 10 R. So N times I is 10 E by R. So again, R. Sorry, there's some issue here. 10 times voltage upon resistance. This is, sorry, this R is in the denominator, 10 R. Voltage upon resistance, yeah. So E by 10 R, yeah. So now it will cancel off. You will have E. So N is nothing but 100. Yes. Okay. Then xt graph of a particle performing, xt is the displacement versus time graph of a particle performing SHM shown in the figure. Acceleration of the particle at 2 seconds here. Right? So acceleration is minus omega square x, that's all. So all I have to do is let's say another color. So 45, so it's 44. Okay, 45 acceleration is so 4 pi square f square. And what is the x value? The x value is 1, because at t equal to 2, if you see in the diagram, at 2 seconds, it's very clear, 2 seconds, time 2 seconds, the value of x is plus 1. So all I have to do is figure out omega. So it's minus 4 pi square f square. So what is the frequency of this? So what's the time period? Well, the time period is positive half, negative half cycle, Milaki is 8 seconds. So if the time period is 8, then the frequency is 1 by 8 squared. So I have 4 pi square by 64. Again, 16 is a. So minus pi square by 16, is that an option? Yes. Okay. So again, this let's find out 46. Okay, 46. Let's see. Wire is carrying a current I along the positive x-axis, has length L. Okay, so the wire is along the positive x-axis and its length is L, and it's carrying current I. Okay, positive x-axis. This direction is x equal. Okay. So it is kept in a magnetic field B bar. So can I say L bar is what then? The L bar is magnitude is L and direction is x-axis, so I cap. So now B bar is 2I 3J minus 4K. What is the magnitude of the magnetic force? So formula for force is F bar is I L bar cross B bar. That's all I have to do. So keep I outside. I J K. What is L bar? L bar is L I cap 0J 0K. B is 2I 3J minus 4K. Right. So we have I cap. We will say 0 minus 0 minus J minus J. So minus 4 L minus 4L and 2 into 0 is 0. Then plus K. So I get 3L. Now again 2 into 0 is 0. So what do I have left is the F bar is 0I. So forget I. Minus minus plus. So 4LJ and 3LK and multiply that by I. So 4IL J cap, 3IL K cap, and they only want the magnitude. So all I have to do now is mod F is root of 16 I square L square, 9 I square L square, so 25, so 5 IL. It's this one. Okay. Question number 47. So in the figure shown here, what is the equivalent focal length of the combination of lenses? So I have three lenses, two plano, this would be plano concave, right? Plano concave lens, and one biconvex lens. Okay. So equivalent focal length, or assume all layers are thin, N1 is 1.5, N2 is 1.6, R1, R2 both are 20 centimeters. So fine. So let's just find out the focal lengths one at a time. So one thing I can say is that F1 and F3 would be the same. Okay. So mu2 upon mu1, so outside we will assume air. Inside for the liquid lens is, I mean, I'm assuming it's a liquid. Okay. So is N2 1.6 minus 1. Okay. And 1 by R1 minus 1 by R2. So if I talk about, let's say, this lens, the first one, first radius of curvature is infinity, so 1 by infinity is 0, you can ignore that, minus, what about this one, the radius of curvature is on the right hand side, so I would say positive 20, so minus of plus 20 is minus 20. Centi is minus 2, so it goes, the numerator becomes plus 2. So what do I have now? Focal length, 1.6 minus 1 is 0.6. 0.6 is nothing but 6 by 10. 0 minus, actually, instead of keeping, because the final answer is in centimeters, so let's just keep it in centimeters. So let's just keep it as minus 1 by 20. So I have minus 6 by 200, or 2 3s are, or just keep it like this, keep it minus 6 by 200 per centimeter. It's 1 by centimeter. Okay. And what about F2? So let's find that out. 1 upon F2, that would be mu2, so outside was 1.5 now for the lens. Okay. The outside medium is now 1.5. I mean the inside medium now is 1.5. So 1.5 upon 1 minus 1. 1 by R1 plus 1 by R2. So both are 20. So this is going to become 2 by 20. So I have 0.5 and 2 by 20, positive 1 by 20. So that's it. 1 upon F equivalent is 1 upon F1 in contact with F2 in contact with F3. So I have F1 and F3 both has minus 6 by 200. So that is twice minus 6 by 200 plus 1 by 20. Okay. So I'm going to get 1 upon F equivalent is going to become LCM is 200 minus 6 to the 12 plus 20 into 10. So I have minus 2 by 200, or I have minus 1 by 100, but I have F equivalent is minus 100 centimeters. Is that an option anywhere? Yes. What is this option? Okay, 48. So a horizontal bridge is built across a river. A student standing on the bridge. So there is a bridge, and this is like my river, and there is a horizontal bridge. Okay. A student standing on the bridge throws a small ball vertically upward with a velocity 4 meters per second. The ball strikes the water surface after 4 seconds. So what is the height of the bridge above water surface? Okay. So look at the side view. So this is the top view. So from the side, he's throwing from the bridge. This is the bridge, and this is the river below it. So he's throwing it up with a U. How much is the U? 4 meters per second. The acceleration is down, minus g, and the ball strikes the water surface after 4 seconds. So the time it has traveled is 4. So what is the height of the bridge above water surface? So this height is what they want. Fine. So let's just use kinematical equation and say S is equal to ut plus half at square, or yeah, I think that's the best thing to do. Ut plus half at square. So what is the S value? All follow the sign convention. All upward vectors positive, all downward vectors negative. So S value is minus h. It goes down. Ultimately starts from here and it ends here. So the S value is minus h. Initial velocity u is upward, so positive 4. So 4 into t, which is 4. Half of a, but a itself is negative, so I would say minus g. They are not saying anything, or they are saying g10, so let's say 10. And again, 4 square is 16. So that's it. So I have 4 4 is a 16 minus 8 into 10 is 80. So I have minus h is equal to 80, 70. I have 676 bonds, so 64. So is that an option? Yes, that is an option. Okay. Ray optics again. Two thin lenses are of same focal length, f, but one is convex and the other one is concave. That means one is f, other one is minus f. When they are placed in contact with each other, the equivalent focal length of the combination is very simple. 49. 1 upon f equivalent is 1 upon f plus 1 upon minus f, or it's basically 1 by f minus 1 by f is 0. That means f equivalent is infinity. The equivalent focal length of the combination is infinity, it's not 0. 1 upon f is 0. 1 upon f equivalent is 0. Yeah. Fine. The last one, question number 50. Let's see the question first. So there is an electric dipole. Dipole is placed as shown in the figure. We have plus q, minus q, and 3 centimeters, and then this is 5 centimeters. Okay. So the electric potential in 10 raised to 2V. So that means into 100 volts, right? So they want the potential in volts, but whatever is the answer, multiply that by 100. At point P, due to the dipole, is what? So they want us to find out potential due to dipole. So I'm just going to simply use the formula. So I think let's go to the next page. So yeah, potential due to dipole is 1 upon 4 pi epsilon naught p cos theta upon r square minus l square or square theta. Okay. So what is the theta value? Theta is the angle made by the r bar with the axis. So here it's 0. So cos 0 is 1. So I have 1 upon 4 pi epsilon naught, which they want us to take as k. Okay. So let's call that as k. P cos 0 is 1. Okay. R square. So what is the r value? It is 5 centi. So 5 centi square minus, again cos 0 is 1, so ignore that, L. So what is L? L is 3 centi. So 3 centi square. So again, this is quite easy. Kp upon 25 into 10 raised to minus 4 minus 9 into 10 raised to minus 4, which goes in the numerator, becomes 10 raised to plus 4. So I have Kp by 16. 10 raised to 4, but they want the answer in terms of Q. Fine. So what is P? P is Q into 2L. And what is the 2L value? The 2L value is 3 plus 3, 6 centimeters. Centi, 10 raised to minus 2. And then I still have the 10 raised to 4. So in terms of 10 raised to 2, ultimately, 10 raised to 2 volts, because this is going to be 10 raised to 2 volts, I'm going to get KQ into 3, 2 3s are 2 8s are. So 3 by 8. 3 by 8 QK 10 raised to 2. So that is this one. Okay. So I hope you had a good exam, and best of luck for the results.